Thank you for taking time to join in for today's webinar on retail analytics using machine learning and predictive modeling. So to begin with, let me talk about a few important key aspects which are changing in the retail industry. Uh, as we all know, data is available all over, and I think every company nowadays are self-sufficient and they are improvising their infrastructure and the technology facilities to make data available in an easier manner for them to be used. So I'll probably try to relate each of these points with a real life example. Probably all of us would be undergoing through real life examples how predictive analytics is being used in the retail industry. So adoption of machine learning and deep learning algorithms. What do I mean to say by this is probably take a retail industry, an e-commerce website, what we see on Amazon, what we see on Flipkart, Myntra. There's a lot of data, there's a lot of user data. Every click we make, every web page we view on the website for a longer time, or every click-through rate, pay-per-click, all this data is being captured, and Amazon is making custom recommendations for the users to improve their sales and to give us a better customer experience. Use of micro segmentation for better decision making. So talking about this, one example I could give is banks have been using micro segmentation algorithms, a lot of algorithms like clustering and classification models to mitigate risk, because in the banks, if you see, they classify customers or accounts based on risk classification. So every risk is associated with the cost to the bank. So they are continuously using reinforced learning techniques based on users' spend, based on users' geography, based on users' payment patterns. So based on that, they are trying to learn on a daily basis to to assign the risk values associated with the customer on a reinforced learning method. So this helps them to answer, probably the risk and the promotions and the campaign, the marketing activities, what they can perform. So omni-channel data integration and spend optimization is, if you take a retail industry, say probably giving an example like Landmark or a Shopper Stop, they have customer data, they have loyalty data. So all of these data warehouses and databases sit in a different environments. So what companies and industries are trying to do now is they are trying to bring in all the data to one single platform, wherein they can have a complete holistic view of a customer. Or talking about, you can see this in different dimensions and aspects. If I'm talking from the marketing point of view, they want to see everything related to every data point related to marketing in a single view. So probably they have dashboards integrated with other systems, like companies have started moving into Tableau, ClickView, and Power BI. There are advanced cognitive visualization tools which are coming up. So they want all the data to be integrated into a single source or single point. So each and every dimension can be connected, and probably business decisions can be made just by looking at one single dashboard. So dynamic pricing to increase sales is most of the retail industry and e-commerce websites. You see, pricing is dynamic, and it depends. It varies from user to user, from time to time, and it's time variant, and seasonality plays a lot of role. For example, a simple example could be if you are checking for flight rates on GoIbibo on a daily basis. The flight rates keep changing, and suppose if you want to purchase a laptop from, say, from HP.com, we visit HP website and we check for the price. As soon as we start looking for the price and start spending some time on the website of a laptop, a chatbot pops up, and probably a chatbot tries to understand what we're looking for, and are we comfortable with the current price zones, or it starts recommending a different product. So if you do that over time and time, the pricing also becomes dynamic, because there's a lot of competition in sales, when especially looking at the pricing aspects. So the companies are trying to be competitive as much as possible without losing their customers out, and trying to not compromise on their margins. and improving assortment management for better customer experiences. This is with respect to a retail store, a brick and mortar store. If you walk into, say, any of the probably giving an example of a Shoppers Stop or a Chroma, we see the placements of products together. So that's because historically they have learned from customers on their point of sales data, on their transactional data, what customers are buying, what 2 or 3 products together they are buying. So they are trying to enforce, or they are trying to force us to start thinking about the product which we didn't plan to buy, by keeping two closely associated products together. So these are a few latest trends, and other thing I can talk about is certain companies in the US have already started using location analytics. So probably all our cell phones are smartphones, and they're enabled with GPS, and it's always the data is on. So as soon as we enter a street, the stores in the company starts pushing us notifications saying, talking about their current offers in the store. So this is real time, and this has been happening in the States recently, and they're trying to engage customers better with the stores, trying to offer better promotions and discounts, so that they don't want to lose a customer. So these are the certain trends and activities which is currently happening around the retail analytics. Moving on to the next slide. Like I already discussed, few focused areas in retail analytics, and where analytics is being used to address business problems is pricing optimization and pricing analytics. Future performance on prediction. So future performance on prediction is basically we have the concepts of test and control when they run out a campaign. So they are trying to see whether that particular excuse me. So they're trying to see whether that particular campaign for a group of customers is working or not. So they release the campaign, or they release the promotional activity to 2 segments of customers, one receiving the promotional activity, and the other group of customers are not receiving the promotional activity. So they are trying to measure if their promotional activity is making an impact in a dollar value for their business, because that comes with a cost and there's a ROI related to it. So based on the current promotional activities, companies are trying to measure and relate if the future predictions on their sales can be increased using such modeling techniques. So demand prediction is again could be linked or could be connected with different dimensions based on supply and demand, based on seasonality. Companies wants to be their inventory has to be ready, their supply chain has to be optimized enough to give the right product at the right time to a customer. So a lot of predictive modeling, like demand prediction, mostly happens in the sales world and the marketing world, where your sales data is plenty and your marketing data is plenty. The data is lying in your CRMs like Salesforce and SAP and stuff. But as a lot of salesmen are finding difficulty in trying to articulate this data to help them to bring in a better conversion rate in terms of sales and bring in a better ROI. So because the highest return on investment ROI opportunity is basically companies are trying to understand which product to be given a promotional activity, or which product they have to focus on that particular season, so that they don't blindly spend on their campaign activities and promotional activities. So 360-degree view is basically for the customer experience activity. Companies nowadays, they are starting to have, every company now have a loyalty card and associated membership ID with them. So over time, they want to perform descriptive statistics and exploratory analysis on their historical data and have a dashboard which gives a 360-degree view of the customer measured on different dimensions like their spend, their demographics, their geographical location, their interest, their social media activity. So all these data points connected together gives them a complete picture of of one individual customer. Probably these focuses currently are on high priority customers, like if you see like elite customers or most loyal customers, because they are in a fear of not losing such customers to their competitors. So companies are slowly trying to adapt to trying to move from Excel based reports to visualization tools like Tableau and ClickView. So in-store analytics again talks about certain companies in US. I think one of the regions in Walmart started to use IoT and artificial intelligence to measure the impact of product placement. They are trying to assess or evaluate what should be the rack size, what should be the length of the rack, what should be the breadth of the rack, where the product exactly has to be placed in the store for maximum coverage and maximum visibility. So companies are using advanced modeling techniques like AI, basically trying to see how long a customer is looking at the product in the store, what information is he reading. Once he sees this product, how long is he spending on the competitor product. So in-store analytics is all about this. So basically in-store analytics is all about this. Slowly companies are trying to adapt and trying to give a better customer experience, and trying not to lose their revenues or sales to the competitors. All right, I'll move on to a real life case study. So giving a background about this business problem. All right. So what I'm trying to do here is I'm trying to increase the revenue sales of low spend accounts of a commercial business. So I'll just give a background about this particular problem. Oh, sorry. So the customer was a retail giant. Basically, they were into commercial business, B2C than B2B. So in B2C, when I say B2C, their account classification done based on the customer historical spend and behavior. They had low spend accounts, they had medium spend accounts, and they had high spend accounts. So the high spend accounts could be like the global 500 companies. Medium spend accounts could be somewhere a mid-sized company, and low spend accounts could be like probably a company with employee size less than 100 or 200, where the requirement is less, and they relatively buy for lower monetary value and for probably a lower frequency compared to medium and high spend. That's how you can distinguish between three segments. So, but for their commercial business problem, 80% of their account base were coming. 80% of their account base were low spend accounts, and these 80% of the accounts were only contributing to only say around 10 to 13% of their revenue. But since still 10% of the revenue for them was considerably large enough because the absolute value was so high. They had a separate sales team working for only this particular set of accounts. So in that case, probably they had around 50,000 customers or accounts in a year, and these 50,000 customers were being targeted or chased by around 300 salespeople. So it was a challenge for the sales guys to target which customer to focus on, because the account base is huge. They have 50,000 customers, and the average time for sale conversion could be somewhere around 15 to 20 days. So if a sales guy is concentrating on 10 accounts in a month, probably he might be closing somewhere between 10 to 20 deals in a month. So the conversion time takes longer, and the account base was huge. So the sales guys had a problem in targeting the right set of customers for them to bring revenue for that particular quarter. So in that case, they were not sure. They didn't have a proper marketing and strategy plan to focus which accounts. So this model helped them to pinpoint a set of potential customers wherein my conversion rate was relatively high without a model. So without a model could be just probably out of 50,000 customers in a quarter, probably around say 1,000 customers would buy. So so my probability of conversion was very less without the model. But with the model, they were able to increase their sales revenue, and they were able to increase their conversion with less effort, because they were given a set of focused accounts, and they had to target only that set of accounts, so that their conversion also increases and their ROI also increases. So that was a business problem. All right, I think I have a question. Let me. I'll finish up this explanation, then I'll come out to the questions. Okay, so what we did is to measure the performance. As a beginning, or we tried brainstorming the problem, considering the seasonality effect, or which part of the quarter, which quarter of the year we were dealing with, and how many data months to consider, how many data points to consider. So we collected data for 1 year at a quarterly level. Basically, what we did was we considered 20 quarters of the data. So we considered 20 quarters of the transactional level data. Like in the 20 quarters, we calculated certain metrics like recency, frequency, monetary, start date, in the 20 quarters time frame, which is the first quarter they purchased, and which is the last quarter they purchased. So let me give a little insight about what are recency, frequency, and monetary. In marketing world, RFM analysis. There's something called RFM analysis. It is one of the easy methods to implement, and that my RFM analysis helps to make your marketing strategy better. So RFM are three terms. Our recency stands for out of the 20 quarters data, which is the recent quarter they purchased. Frequency is out of the 20 quarters, how many times they have purchased. Monetary is total sum of value they have purchased in the 20 quarters. So we use these variables as an input to the model, and we calculated also their year-on-year revenue change, whether this particular customer has been growing year over year, or whether he has been his association with the company has been decreasing year over year. So we concluded with these variables as an input variable to the model. We developed three models. One was the logistic regression, one was random forest, and the other was artificial neural network. So what we're trying to see is what the end objective of the model is to say, out of the 20 quarters historical performance data, I am going to predict whether this customer is going to buy a product from me or not in this particular quarter. So that's the end objective. That's my target variable. So target variable will be whether the customer is going to buy this quarter or not. So once we predict as a next step, what we did is there's a concept called collaborative filtering. So collaborative filtering works. So an example of collaborative filtering could be what you see in Amazon. If you have viewed something, if you have viewed a product on Amazon, get an immediate recommendation saying that people have bought who have viewed this have also viewed this. So that's a recommendation engine which works, which gives you a real-time recommendation based on other users and other patterns. So once we decide on these are the set of customers who are the potential customers who will be buying this quarter, we wanted to see what they will be buying. Because this will help the sales guys, to engage for them in the conversation. So, for example, now I'm saying that you will be buying this quarter, but even if I know what you would be buying, it makes it easy for the sales guy to come up with a proposal, and it propose it to you, so that uh, there's a better relationship which is growing between the sales guy and the potential customer, because they think that we understand the customer better, and we can offer a tailored solution or a customized solution for them. So we analyzed their product level purchase for the last 20 quarters, and based on their product level purchase, we developed a collaborative filtering model trying to understand what are the top 5 products they would be interested to buy in this quarter. So if you notice one thing, all this is time variant. We have considered seasonality into effect. That's why we have considered 20 quarters data, because it probably can overcome the problem of the seasonality and stuff. So when we are treating with this data, so as one of the mandatory process, or as a data sanity checks, what we do in the model development activity, we check for missing values. We impute the missing values with certain imputation methods, like replacing with mean, average, or you can use advanced techniques like PCA and stuff to replace the missing values. Then we check for outlier detection and influential observation detection. So outlier detection is, for example, say based on the transactional amount, I plot a distribution of my customers. My 99th percentile customer, say, contributes to that 1% of the population could contribute to 20% of the overall revenue. So that one particular population, 1% of that population, is an outlier for me, because they're contributing to 20%. So those are the outlier treatments which we tried analyzing. Based on that, we capped our upper limit and lower limit as $62,000 and $100 as a minimum limit. Move on to the next slide. I've listed the assumptions here, certain assumptions which we have made following outlier and influential observation analysis. So this is the approach we carried out before we developed the final model. So we did the data cleansing, checking for the missing values, and checking for junk values, and checking for garbage values. Then we did the outlier treatment, and then we checked the multicollinearity between input variables. So here in this case, I had 7 input variables: my recency, frequency, the first purchase rate, the monetary. The density is basically I'm trying to assess, in the 20 quarters of the data, how the customers have have purchased in the consecutive time frames. Like, probably the customer has purchased 5 quarters together and he did not purchase at all, or how is their purchase pattern within the 20 quarters. So my density variable calculates that, assesses that risk. Then we check the input variable normalization. Since we are considering monetary, we have to scale it, and we have to standardize the variables. We use normalization method. Then we develop the data. We develop the data into train and test. 70% was in-time validation, and out-of-time validation was 30%. That is my train and test. So based on random forest model, we came up with important variable using mean decrease accuracy and mean Gini coefficient. So based on that, we could confirm only the top 4 variables were the most important variables which had the highest impact for the customer prediction. Since I would not like to get into too much detail on the technicality, I think since the audience are quite generic, talking too much on the technicality might confuse others. So I'll just give an overview of what the model does and how the modeling activity was done. So once we decided on the train and the test data, on the train data we developed three models separately: the logistic regression, random forest, and artificial neural network. So once we developed the model, we evaluated the model performance using different performance metrics, like we check for sensitivity, specificity, Gini coefficient, AUC, confusion metrics. We check for the out-of-bag error rate, the type 2 error rate and the type 1 error rate. So if we are talking about random forest is a ensemble technique, and it doesn't require out-of-time validation because it uses the bootstrapping method. So we did a tree pruning, and then we fine-tune the model. So once we fine-tune the model, we try to implement the test data into the model, and we see the performance, how the model is performing for the test data. So the reason why we develop the model on the training data and test it on the test data is to make sure there are no overfitting problems. When I say overfitting problems is, for example, in a layman term, to make it clear, suppose I am trying to predict for a set of 100 customers, and say that's a model I've developed to predict for a set of 100 customers. So in the future, if the customer's attributes or the behavior changes, and my prediction, if I'm not able to predict it right for the future set of data, which means my model was tuned only for that particular set of data, which means it's able to consider or mitigate the risk or the variances only with that particular data, and it's not able to predict accurately for the new set of data. So that's an overfitting problem which usually happens in analytics or the predicting world, but certain advanced techniques like neural networks and random forest, the algorithm itself can handle it within itself. Few details. These are the output of the model. We had an accuracy of 78%, overall accuracy in terms of prediction whether the customer, which customer bought and which customer did not buy. Recall, we had 67%. I mean, recall is basically, I'm saying that which particular customers bought when I actually predicted them that they bought the product. So my target variable, basically it will be 1. The value will be 1. These are the technical details on the random forest model. The number of trees we chose, what was the node size we chose, and MTRY is basically a number of iterations which have happened. And here we are calculating the out-of-bag error rate for n number of trees. For 50 trees, the out-of-bag error rate got down. So there's no point building the, there's no point extending the model after 50 trees. So we stopped building at 50 trees. One of the reasons why the industry even now, they rely a lot on logistic regression over other advanced advanced algorithms is because its intuitivity and the business justification and explanation is much easier with logistic regression. For example, in random forest and artificial neural network, I will be able to say whether this customer will buy or not, but only to a certain extent I can see which particular predictor or explanatory variables are impacting my outcome. But with logistic regression, with the coefficients of the independent variables, I can explain it in the I can explain to the business with a much better sense, saying that if the customer's recency was increased by 1 more unit, the probability or the odds of the customer will buy increases by a certain extent. So those are the certain advantages which we have with respect to logistic regression over the new developed techniques. But again, this comes with pros and cons, wherein the pros are we assume though certain linearity has to be there between the dependent and the independent variable, and normalization and scaling of the independent variables and stuff. So going to the collaborative filtering, so what we did is once we developed the model on the 3 platforms, my logistic, my random forest neural network, based on the best model's performance, we decided to go with random forest because that gave us better results. So out of 50,000 customers, we came up with a list of say 3,000 customers which had a higher predictor score or probability that they would buy in this quarter. For those 3,000 customers, what we did was we went back to the last 20 quarters and we checked what kind of products they purchased. We took their transaction level data at a product level and we built a collaborative filtering. So how collaborative filtering works is something similar to market basket but works on the cosine law. It can be developed on a user to user or a product to product. So we developed it on the product to product methodology. So what we are trying to say is for those 3,000 set of customers, we gave the sales guys a leverage or an advantage to talk about the top 5 products the customers would be interested in. So when we developed this whole solution and implemented in one region, we observed increased revenue of 14%, and the conversion rate of those 3,000 customers were on 62%. So without the model, the conversion rate was somewhere around 30%, and the revenue was like probably somewhere less. But with the model, we were able to streamline the process and help the sales guys to increase their sales targets and bring in the revenue by 14% and the conversion by 60%. So yeah, this example is with respect to the retail industry for B2B industry. But again, like I said, there are advanced techniques, and the same problem could be addressed in different ways. This is all I had for the discussion for today. Thank you all for taking time to go through this webinar.